Hello, students. Welcome to Biowise with Aanchal. I hope everything is going on well and the preparation for the exams are also fine. Now, before moving ahead with this video, I request you to like, share, and subscribe the channel and then proceed with the video, which talks about the action of heat on compounds and also flame test. So let us move ahead. Now, here, the first compound that I have taken is mercuric oxide. The reaction is given to you. Now, when two molecules of mercuric oxide is heated strongly, you'll find a silvery mirror-like deposit on the test tube, walls of the test tube, and a gas is released. Now, the gas released rekindles the glowing splint. That shows that it is oxygen gas. Very good. Now, color of the mercuric oxide is orange color, that is orangish red color. You can see it in the picture. Now, the gas released is oxygen. So I have already made a video on the that is important gases. So there with the picture illustrations, you have the complete observation of the gases. Here I have just mentioned colorless, odorless gas is released, which rekindles the glowing splint. This is the test for oxygen. There's one more test for oxygen where you talk about the alkaline paragalol solution turning brown. Right? Now here, if you talk about the residue is silvery deposit on the walls of the test tube. Children, there is a difference between a residue and a precipitate. Precipitate occurs when there is a solution. Insoluble salt in a liquid medium acts as a precipitate, but residue is something which is left behind after heating. So when you strongly heat a substance, whatever is left behind is the residue. Do not get confused between the residue and a precipitate. Okay, so here the residue here is the silvery deposit on the walls of the test tube, that is mercury, nothing else. Okay, so this is the action of heat on mercuric oxide. Next compound is copper carbonate. Copper carbonate is a light green color salt. This is appearing little bluish, but it is light green in color. You can easily identify the color. Light green color copper carbonate, when it is heated strongly, it produces a black residue and a gas is released which turns slime water milky and has no effect on acidified KMnO4 and acidified potassium dichromate solution, showing that it is carbon dioxide and not sulfur dioxide. Now, on strong heating, the residue obtained is a black residue because copper oxide color is black. Copper carbonate color is light green. So, what will you observe? A light green salt changes to black residue by evolution of a gas which turns lime water milky and has no effect on KMnO4 and K2Cr2O7 solution, right? Next one is zinc carbonate. Now, zinc carbonate is a white color salt. You'll find that now this salt is chalky in appearance, and it when it is heated strongly, it again gives, since it is a carbonate. So you know that whenever a carbonate is heated strongly, carbon dioxide gas is released. So colorless, odorless gas is released, which turns lime water milky and has no effect on KMnO4 and K2Cr2O7, as I have told you before. Now here the residue which is formed is pale yellow, which is similar to lead oxide. But there is a difference between zinc oxide and lead oxide. Zinc oxide is yellow when hot and white when cold, but lead oxide retains the yellow color. So that is how you can differentiate it's a lead carbonate or a zinc carbonate compound. Understood? So lead carbonate and zinc carbonate, they both give you a pale yellow residue. But if you leave it to cool down and it turns white, it tells you it is zinc. Okay. Moving to the next, that is copper sulfate. Now, copper sulfate pentahydrate is a hydrated salt which is called blue vitriol. So, when blue vitriol is heated strongly, first of all, it will lose moisture and an amorphous white color substance, that is copper sulfate, is formed. Now, when you keep on heating this copper sulfate, it changes into copper oxide, which is a black residue, releasing gases like sulfur dioxide and oxygen. Now, sulfur dioxide, like carbon dioxide, turns lime water milky, but at the same time, it also decolorizes KMNO4 from pink to colorless and also changes the color of potassium dichromate from orange to green. Okay. So here I have not mentioned here what is the change. You write down acidified KMNO4 colorless and acidified K2Cr2O7 solution. It turns from orange to green. Understood? So you will find here it is from orange to green color. Understood? That is how the color change. This is given in the previous video of important gases. So the original color of K2Cr2O7 is orange. It changes into green solution, clear green solution. That is how sulfur dioxide is tested. Okay. Now it's a colorless, odorless gas release which rekindles the glowing splint. When you have a glowing splinter, it also rekindles into flame. The rekindles means it bursts into flame, showing that there is one more gas which is oxygen. On heating blue hydrated solution, you'll find blue hydrated salt changes into white amorphous salt, and on heating strongly, a black residue, as I've already explained. Any doubt, put it in the comment section. Now, zinc nitrate when heated strongly, it gives you zinc oxide, again yellow when hot and white when cold. A reddish brown gas, which is nitrogen dioxide, and oxygen. Now, since oxygen is a colorless, odorless gas, it comes out with nitrogen dioxide. So you cannot say that the color of the gas. But here, if you have the glowing splint, it will burst into flame or rekindles the glowing splint that shows the presence of oxygen. So the color of zinc nitrate is white. Reddish brown gas is released, which turns moist blue litmus red, and acidified ferrous sulfate solution brown. The acidified ferrous sulfate solution. What is the color of ferrous sulfate solution, children? Write it in the comment section. What is the color of ferrous sulfate solution? And it changes to brown. The gas released rekindles a glowing splint, confirming the presence of oxygen. And on strongly heating, yellow residue is obtained, which turns white on cooling, showing that it is zinc oxide. Okay. Next one is copper nitrate. Copper nitrate on heating gives you copper oxide, nitrogen dioxide, and oxygen. Any nitrates will give you almost the same reaction. Thermally stable nitrates do not react like that of potassium and sodium. Now, when you see the color of copper nitrate, it is blue in color. When it is heated strongly, it gives you copper oxide, which is black in color. So here you have the formation of a black residue, not precipitate, a black residue. Reddish brown gas is released, which turns moist blue litmus red, showing it's an acidic gas, and acidifies ferrous sulfate solution brown. You have to tell me the color of ferrous sulfate, okay? And the gas released here rekindles the glowing splint. On heating, black residue is obtained. Okay, moving to the next, lead nitrate. Now, lead nitrate is also a white salt. But when you heat lead nitrate, it starts making noise. That is called decrepitates. It decrepitates and melts. Chit, 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 like that sound is produced. That is decrepitation. So it decrepitates and melts, and then a yellow residue is formed, which is the litharge, PbO, which fuses with the glass. Okay. Now, and the gas produced here also is nitrogen dioxide and oxygen. So you can write lead nitrate is a white crystalline salt. Reddish brown gas is released, which turns same observation. A gas released rekindles the glowing splint, and on strong heating, the salt decrepitates, melts, and yellow residue is obtained, which fuses with the glass. Now, this is the observation for strong heating of lead nitrate. Now, there is a specific name for these heating reactions. Okay. You know what? These are all decompositions. So, since heat is involved, it is thermal decomposition reactions. Okay. Moving to the next, ammonium chloride. Now, ammonium chloride is a sublimable substance. What happens when you heat ammonium chloride? It changes into ammonia and HCl. Ammonia, the basic gas, and HCl, the acidic gas. They both combine again and form NH4Cl and gets condensed on the cooler part of the test tube. So finally, what happens? Nothing is left in the test tube. Everything sublimes. So here you observe that the color of NH4Cl is white crystalline. It sublimes on heating and gets condensed on the cooler part of the test tube, and there is no residue left behind in the test tube because everything heats up, gets sublimed, and changes into vapor, and again condenses on the solid part of the that is on the cooler part of the test tube. Ammonium dichromate. This is a very interesting reaction. I hope you all have seen this reaction. And this reaction, what happens? Ammonium dichromate is a orange color salt. So when you heat it, it reaches its ignition temperature, it catches fire like things, and it starts changing into chromium oxide, which increases its volume, and you will find a small spark like thing coming out from the voluminous hill, and it appears as if it is a green volcano. The name is also the green volcano reaction. The color of ammonium dichromate is orange. On heating, it decomposes violently with a flash of light, leaving behind voluminous green residue of chromium oxide. Okay, it is also referred as green volcano reaction. Okay. Now, next topic is flame test. You should know how the flame test is done. Now, for the flame test, thin platinum wire, first it should be cleaned, that there is nothing on it, and then heated in a non-luminous flame till it imparts no color, showing that there is nothing on the platinum wire. Now, why platinum wire? You know that it's the non-reactive metal. That is why platinum wire is used. When the wire imparts no color, it is dipped in concentrated HCl and then into the salt containing the metallic cation to be identified. Now, the wire is then reintroduced into the flame, and you'll find that there is color imparted in the flame. Okay. Now, based on the color, you can identify the which metal is present in the salt. Okay, now this is the procedure. You can see, clean it first on the non-luminous flame till there is no uh, color of the flame imparted. Then an acid treatment is done where it is dipped in the hot wire is dipped in the concentrated HCl. Then rinsed with distilled water. Then it is put in the metallic solution, or you can use the salt directly, and then you put it on the flame to observe the color. When you see these colors, like lithium is crimson red, sodium is golden yellow, potassium is lilac, calcium is brick red, copper is blue green, and barium is apple green. Okay, now you can see this is very important. You can take a screenshot of this slide. It will give you the flame test, and you can easily identify, like there are many reds: calcium brick red, lithium crimson red, strontium scarlet red, strontium scarlet. Okay, calcium in the bricks, the brick red. Lithium is crimson red. You have to learn these colors. These are important. Okay. So this is all their flame colors and the flame test. Thank you for watching the video. I hope you understood the basic concept of heating of the compound, the thermal decomposition, and the flame test. We'll have the next video on the cation analysis. Or if you want any other video, put it in the comment section. I'll get back to you. And happy learning, children. Study well, do well, and keep in touch with Biowise with Aanchal. Thank you so much.